Welcome back. Oblique slant asymptote. So the graph of a rational function has a slant asymptote if the degree of the numerator is exactly one more than the degree of the denominator. It can't just be any amount more, it has to be exactly one more. Okay? If it's more than that, the whole function is just growing so fast, growing without bounds, so fast there's just not even an asymptote at all, any kind of asymptote, or any kind of horizontal or slant asymptote. So if we're 1 degree more, then we're going to have a slant asymptote. To find this slant asymptote, we're going to use long division or synthetic division. To find the slant asymptote. So if our denominator is x plus or minus a constant, you can use synthetic division. If it's not just x plus or minus a constant, then you're going to need to do long division. Okay? All right, so you only have an oblique asymptote when there's no horizontal asymptote. You cannot have both. Right? So it's either or. Okay? So if they're the same degree or the numerator has a smaller degree, you're going to have a horizontal asymptote. If your numerator is 1 degree more, you're going to have a slant asymptote. And if it's more than that, you're not going to have any kind of asymptote at all. When doing long or synthetic division, you do not care about the remainder, just the rest of it. Right? We're going to completely drop the remainder on these. Let's take a look. So now this is the last one because we've already done 6. We've already done functions that can be reduced where we have a common factor. So we are going to be graphing where the degree of the numerator is greater than the degree of the denominator. And this is going to only be by 1. Right? We're not going to do any other functions besides just one difference. This is in your notes. This is where your notes starts. All right, so factor first. Set each factor of the numerator equal to 0. You're going to have, set each factor of the denominator equal to 0. That will be your vertical asymptote. So each value which makes the denominator equal to 0 is going to be a vertical asymptote. It's possible that there's no vertical asymptotes. If nothing makes the denominator 0, it's possible we have more than one vertical asymptote. Okay? And this is nothing new. This is what we've been doing all along in terms of finding the vertical asymptotes. The new part is the slant asymptote. Right? So if n equals n plus 1, and remember n is the degree of the numerator, and m is degree of the denominator. So if they're exactly one more, okay, we're going to have a slant asymptote. Y equals ax plus b is an oblique or slant asymptote of the graph. Oblique and slant means it's going on a diagonal. So it's not horizontal, it's diagonal. And it's found using long or synthetic division. Essentially, it's just the equation of a line. Right? And we'll find that using long or synthetic division. Our x-intercepts are the real zeros of the numerator. So you're going to set your numerator equal to 0 and solve for x. Sometimes you have to factor. Right? When we're graphing, we're going to plot 2 or 3 points on either side of a vertical asymptote. They can include x-intercepts or positive and negative values substitute for x, or y-intercepts. Y-intercept, I should say. We want to find the domain. Our domain is, we're always going to eliminate anything that made the denominator 0. So values that make the denominator of a fraction equal to 0 are not included in the domain of a rational function. And the range, the graph of the function may help you identify the range. So a slant asymptote does not limit the range of a function. And of course the range is y values of the function. So horizontal asymptote limits our function. Slant asymptote does not. Let's take a look at our first one. And the first one is in your notes. Yes, it is. A little faded there, but it is in your notes. All right, so first of all, we want to factor first. We have x squared minus 3x minus 4 over x minus 2. I have it already factored at the bottom there, but I'll go over that with you in terms of factor by grouping. So we would multiply. 1 times negative 4 is negative 4, and the two numbers that multiply to give us a negative 4, but add to give us our b term of negative 3, of course, would be negative 4 and 1. Right, so that would give us, I'll put over here, x squared minus 4x would be a group, and then x minus 4 would be a group. If we'd pull out the x, we'd have x minus 4. We'd pull out 1, we have x minus 4. So all factored, that would be x plus 1, x minus 4. Oh, excuse, in the numerator, sorry. I'm already factoring up. I already have it down there below. Oh, I was not paying attention. Woo, they already had it at the bottom. Well, it's already there at the bottom. Right over there. And it's in your notes, I think. Yeah, so don't write that down. Just follow along over there on the side. I was kind of going ahead of myself. Well, I'm not really ahead of myself because you should always factor first because you want to make sure there's no holes. Now, this obviously would not have a hole because we have x minus, you can see it factored right here, which is what my eye noticed first. You can see we have x minus, so much my asterisk, we have x minus 4 and x plus 1 in the numerator, x minus 2 in the denominator. None of those match. There's no holes. All right, so let's continue with our vertical asymptote, and then we'll go to our x-intercepts, and then we'll find our slant asymptote. All right, so our vertical asymptote, we just set x minus 2 equal to 0, so no problem with that. X equals 2 is our vertical asymptote. Our x-intercepts, we would just, we've already factored the numerator, and we would just set those factors equal to 0. So we have two x-intercepts when x minus 4 is 0 and when x plus 1 is 0. So 4 and negative 1 are our two x-intercepts, so that can be two of our points. Now we need our slant asymptote, and we can use long or synthetic division. I am going to review both with you because I think it's good for you to remember both. However, when you are finding this slant asymptote, you may, if it is x plus or minus a constant, you get to choose long or synthetic. If it's anything else, you're going to have to use long, and we'll see some of those in this particular lesson. All right, so we're going to divide x minus 2, our denominator, into our numerator, x squared minus 3x minus 4. And you've done this before. This is no biggie. This is really nothing new. It's just new in terms of rational functions. So I ask myself, what would I have to multiply x by to get x squared? Well, that would be x. Right? So x goes into x squared x times. X times x is x squared. X times negative 2 is negative 2x. And we remember that subtraction means to add the opposite. Right? So x squared minus x squared would be 0. And then negative 3x plus positive 2x is a negative x. And then we bring down the next one, we bring down the negative 4. And we divide again. So we ask ourselves, what will we have to multiply x by, this x here, to get negative x? Well, that would be negative 1. So negative 1 times x is a negative x. Negative 1 times negative 2 is a positive 2. And I'm running out of room for my subtraction here. And we remember that subtraction means to add the opposite. So negative x plus x would be 0. Negative 4 plus a negative 2 is a negative 6. This is your remainder. You don't care about it. All right? This is remainder. You don't use. It doesn't matter. You're going to get a remainder. Matter of fact, the only way you wouldn't get a remainder is if you could have factored and canceled something. So you don't care about the remainder. All right? So what we do care about is our equation here. And it is going to be a y equals, right? So it is going to be the equation of a line, y equals x minus 1. So that's going to be our asymptote, and we're going to graph that one. If we use synthetic division, right? So I would just use the coefficients, and nobody's missing, so it would just be a 1, a negative 3, and a negative 4. I'd bring down the 1. Oh, so I forgot to write, I'm dividing by x minus 2. So if I'm dividing by x minus 2, x is 2. I forgot to write that in there. All right, so we bring down the first one, and 1 times 2 is 2. We add, we get negative 1. Negative 1 times negative 2 is negative 2. Negative 1 times 2 is negative 2. We add, we get negative 6. Notice it's the exact same value. This is your remainder. You don't care about it. This is the constant, and this is the x. So this equation is y equals x minus 1. So either way, that is our slant asymptote. So now we're going to graph this. All we need is a couple points. and then we'll be fine. But let's graph our asymptotes first. Right? And then if you have questions, I will be going over division a little bit more in class and in the next podcast. I'm probably going to do 3 podcasts for this lesson. All right, so let us graph. I already have my asymptotes graphed. You do not. So graph your asymptotes. You're going to graph a vertical line at x equals 2, and you're going to graph the line y equals x minus 1. You know how to do that, right? This is your y-intercept, is 0, negative 1, and your slope is 1. So you can literally just, this isn't a point on my function, this is just a point on my asymptote. You can just, put a point there at negative 1, and then just, go up and down, up, by 1. All right, so you notice that's just the slope of a line. It has the slope of 1, and its y-intercept is negative 1. That's no different than when we were graphing linear functions at the very beginning of the year. You know how to do it. It's just a line. All right, so we see we have one vertical asymptote. We need 4 points. Right? Sometimes we might need more. All right, but we need at least 4. All right, so let's see. We already have a couple of them, right? We have the x-intercepts. Remember, back over here. So our x-intercepts were negative 1, 0, and 4, 0. So negative 1, 0, and negative 4, 0. I did not find my y-intercept on the other page. Let's find my y-intercept. So if x is 0, y would be 0 squared minus 3 times 0 minus 4 divided by 0 minus 2. Well, I got a lot of zeros in there. And that's going to simplify to negative 4 divided by negative 2, and that's just 2. So there we have 3 points. Let's see, we've got, and they're all on the same side of the vertical asymptote. Did I write down one of these wrong? I feel like one of those was positive. It was a 4. Okay, well that's good. So now we have 2 on the left side and 1 on the right side. We need 1 more on that other side there, at least. So let's try 3, right? So we need 2 that are greater than 2. So let's do 3. All right, and we're actually going to get a nice number. 3 squared minus 3 times 3 minus 4, all divided by 3 minus 2. That's going to give us 9 minus 9, so that's 0. So we're going to have negative 4. And then we have 3 minus 2, which is 1. So that's just going to be, of course, negative 4. So let's try graphing those 4 points and see, does that seem like it's enough, or do we need more points? All right, can we figure out the shape of the graph? So we have negative 1, 0 is right there, and 0, 3. That's fine on the left side, right? That is enough to figure out a shape of the graph. And you're going to know how to do this in a moment. So first of all, this function will not cross this slant asymptote. It will turn, for these points, it will not cross the vertical asymptote. That side is going to look like that. Let's graph the other side. All right, so we have 3 and 4. So 3 was negative 4. And 4 was 0. And I feel that is enough to graph it. If we wanted an extra point, we could get an extra point. So for instance, if I were to plug in, say, 8 maybe, we could find that value. I don't think we're going to need it. And I don't want to take up too much time on this podcast plugging in values. So if you want more points, you can always plug them in, but this is not going to cross the vertical, and it will turn for that slant. It will not cross that either. All right? And that is enough to give us a pretty good idea of the shape of our graph. Right? More points, of course, would make it even more accurate, but that is plenty accurate enough for me. All right, our domain. No different than before. Take out the vertical asymptote. Negative infinity to 2. I'm going to bring it down just a little bit so you can see it. And then 2 to infinity. Well, we're not going to bring that. I thought I could bring that down. Whoops, come on. Oh, my goodness. It'd be easier just to erase it. Things are always slower up here when I'm taping. All right, well, maybe that'll disappear, but I'm going to write it down here regardless. Negative infinity. Oh, come on. Come on. I'm done on this podcast as soon as this comes up. Well, it's not going to come up. All right, so I'm not going to wait forever for that. I'm going to put the pen down and see if that actually erases. I think it's upset with really quickly. Negative infinity to 2 to infinity. There we go. Oh, nothing like technology when it doesn't want to cooperate. And maybe that'll come up. Our range, look at that graph. All right, notice how it's going. Oh my gosh. Well, don't hold the pen in the hand and erase at the same time. Well, maybe I gave you a little chuckle there. Negative infinity to 2 is killing me. There we go. I'm not going to even care that part of my parentheses didn't show up. Well, maybe I'll care a little bit. And then 2 to infinity. There you go. There's your domain. And look at that graph reaching to the sky. Negative infinity to infinity is your range. Oh, the most exhausting thing was writing the domain and range. We're done. That's this graph. All right? We're going to graph another one, I think, on the next podcast. I know this is a little bit much, but I don't want to get us too far behind. So I'm going to end this one. We'll do one more graph, and then the rest in class. Okay? Bye for now.